Something that we might notice from finding complex zeros using either the square root method or the quadratic formula is that they tend to show up in what we'd call conjugate pairs. If a plus bi is a zero of a polynomial with real coefficients, then a minus bi is also a zero. Turns out this isn't just something that tends to happen, this is something that has to happen. So anytime we know one non-real zero, we also immediately can tell what one other non-real zero is. In this case, if we're told that 3 minus I is a zero of this polynomial, then we know that so is 3 plus I, the complex conjugate of 3 minus I. So even though we were only given 2 zeros here, this is a degree 3 polynomial, it turns out we actually are implicitly given 3 different zeros of this. We're going to construct this polynomial from its factors. First of all, the 0, 3 minus I gives us the factor x minus 3 minus I, which we could also write as x minus 3 plus I. The 0, 3 plus I gives us the factor x minus 3 plus I, which we could also write as x minus 3 minus I. We have one more 0 here, which is actually the number 0. So x equals 0 is our last piece of information. This is going to give us the factor x minus 0, which of course is the same thing as just x. So putting this all together with also the leading coefficient that we're given, a sub n is equal to -2, we can get our factored form right away, starting with our leading coefficient of -2, then our factor x, and then our two factors that have some imaginary coefficients. The expanded form of this same polynomial is what I would get by multiplying out all of these factors. So we have two different options for how we could proceed with that. One way would be to just multiply this out. We have a 3-term polynomial multiplied by a 3-term polynomial. So if we do this in the most straightforward way, that's going to result in 9 terms before we start combining like terms and perhaps canceling out any terms that add up to 0. Another way to do this is to back up the process of completing the square. So I'm going to follow that way first, and then I will also show what this could look like if we were to choose to just multiply out the factors. So starting with completing the square, the idea is this. I would say I'm given that x is equal to 3 plus or minus I as 2 of my zeros. I'm going to get the plus or minus term alone on one side and everything else on the other side, which looks like this. X minus 3 is equal to plus or minus I, because this way I can go ahead and square both sides and that plus or minus will go away. It doesn't matter whether I started with a positive or a negative before squaring. It's going to become, well, in this case, -1. So the left-hand side becomes x squared minus 6x plus 9. And the right-hand side becomes -1 because I squared is -1 and minus I squared is -1. Then I can finish this by adding 1 to both sides to get x squared minus 6x plus 10 equals 0. That means that 3 plus or minus I, those two zeros, are zeros of this quadratic. So I can accept this now as one factor in my polynomial, and the other factor I already have. That's the -2x from above. So now all I have to do is distribute -2x into this polynomial. and I will get my fully expanded form, which I will go ahead and write up here. That's going to start as negative 2x cubed, then plus 12x squared, and finally minus 20x. So this is the easiest method, but it's not the most obvious method. So if this method is too confusing or too hard to remember, let's see how we can go about this by just multiplying out factors instead. What I'm going to do for this is start with this more grouped form of the factoring that I have over to the left. Starts with negative 2x, and then we have x minus, and I have that 3 plus I still in parentheses, and x minus with the 3 minus I still in parentheses. The reason I'm doing this is treating that as if each of these factors had two terms is going to allow me to use FOIL, and it's going to allow me to group things in such a way that makes the products a little simpler. So I'm going to leave this negative 2x alone for now and just focus on the FOIL. The first term is x squared. The outer is going to be minus x times 3 minus I. The inner term is going to be a minus x times 3 plus I. And the last term is going to be plus 3 plus I times 3 minus I. Okay, before I distribute in the negative 2x, I'm going to do as much simplifying as I can on the inside. I need to distribute these. And I also need to multiply out this 3 plus I times 3 minus I, but writing it in this form allows me to take advantage of the fact that what I have here is a product of conjugates. So I have my negative 2x still on the outside. Now x squared minus 3x plus ix minus 3x minus ix. And finally, here at the end, I have 9 minus I squared when I use the difference of squares formula to multiply that. So the plus ix and the minus ix drop out, which is how it is that the conjugate zeros allow me to have entirely real coefficients, because even this I squared here isn't really an imaginary number. I squared is the same as negative 1, so after this step I won't have any imaginary numbers left in my expression. So the negative 2x, let's leave out here for one more step. I have x squared as my first term. Combining these x terms gets me negative 6x. And combining these numeric terms here, 9 minus negative 1, gets me that same plus 10 that I saw with the other method. Now I can see that if I just distribute, I'm going to get the same thing that I've already calculated in my expanded form blank up here. So it's more writing for sure. The other way is cleaner, but this might be a little bit more intuitive because it's always following the same approach, which is building factors, multiplying out the factors.